All right, here's part 2. Okay, so now that we know the symbols, now we need some rules. Okay, so we're going to write down the rules on how to write chemical equations. Basically, what we're going to do in this section is we're going to take words and create symbols and formulas and make a sentence that's a little smaller, like an emoji. Okay, so some basic rules for putting your chemical equations together correctly. Like in English, you always read from left to right across the page. So you start here and you end in this direction. Okay, that's the easiest one. Oops, sorry. All right, so number 2, the equations have 2 halves. We have the reactants and the product side. And remember, the arrow is always pointing to the products. So on the left-hand side is the reactants and the right-hand side is a product. So make sure you're writing these things, all of these down, okay? All right, oops, let me go back. All right, so compared to English, you now know everything you need to know to write grammatically correct chemical equations. Let's go ahead and do some, okay? Let's translate the following equation into a chemical formula. All right, so we have words, lots and lots of words, okay? So we have hydrogen chloride. Well, hopefully you know that hydrogen is H, chloride is chlorine, okay? And you must remember that there is a positive one on a hydrogen and a negative one on chlorine. They're going to crisscross, and that's how we get HCl. In the liquid phase, remember that symbol for liquid? Okay, and, there's a plus sign, okay? Sodium hydroxide, NaOH. In a solid phase, there's an S. Yields, and I'm going to get a smaller pen here in a minute, aqueous sodium chloride, NaClAQ. And remember, these go in parentheses. The liquid, the solid, and the gas are all in parentheses. And water, okay? And H2O. And water is a liquid, okay? So let's see let me go back down here just a little bit. And is that what we have? Yes, it is. Okay, so if you didn't follow mine, you can go back and see what we did here. Okay, I am going to change my pen for a second. Thickness. Okay. Okay, so again, here's where we start. You got hydrogen, you got chlorine. You should be thinking these are positive and negatives. Okay, crisscross in liquid phase. So there's your L. And there's your plus sign. Sodium hydroxide, Na. OH. Remember, this has a +1, has a -1. In the solid phase, yields, there's my arrow, aqueous, AQ. But one thing you need to know, even though this word is in the front and sodium chloride is in the back, do you notice that the aqueous goes behind it? It's because any of our phases are always behind or after our substance. Okay? And then we have sodium, NaCl. This is again plus and minus, and water is H2O. And you know that water is a liquid. You should anyway, unless it tells you that water is in a solid phase, which would be ice, or in a gas, which would be a vapor. Okay? All right, let's try another one. Okay, so here's our equation right here. It says fluorine gas reacts with solid sodium chloride to form solid sodium fluoride and chlorine gas. So first thing I would do is this. Okay, I got fluorine gas. Okay, so I have an F. All right. I know that it's a gas, so I'm going to put a G. Reacts with. Okay, so I need to put a plus sign there. Remember I told you that reacts with could be also and or combines with. Anything that says that with in there is going to be a plus sign. Solid sodium, and it has to have a plus, and chlorine has to have a chloride, has a negative, to form solid sodium fluoride. There's a plus, there's a minus. This is how I would work these problems. And chlorine gas. Okay, now there is a problem here. You remember that old Brinkelhoff? Brinchlhof. Remember I said they are diatomic molecules? Okay. Diatomic molecules, they cannot be alone. Okay, diatomic molecules. So fluorine has to have a 2 and chlorine has to have a 2. Why? Because they cannot be alone. They have to be attached to itself or something else. So we have fluorine, and we said it had to have a 2, gas, plus NaCl, because we're going to crisscross, and it's going to be a 1-to-1 solid yields, or to form. That's also a yield, okay? Sorry, I forgot about that one. A solid sodium fluoride, again, they're going to crisscross, and it's going to be NaF plus Cl2 gas. And I think we had a solid here, so you just plug everything in, okay? I'm not too concerned with balancing right now, but if I was, you could balance this by putting a 2 here and a 2 here, and it's a 1-to-2-to-1 ratio. Okay, I probably will have you balance these equations because we do use balance equations all the time. So I'm going to stop the video for a second and I'm going to give. All right, now it's your turn. I want you to bring this to class. I want you to write the equation for sodium reacts with water to produce aqueous sodium hydroxide and hydrogen gas. Okay, bring this to class. I'll see you in class.